we see the switch theorem. Okay, Mayan?
Yeah.
So here it is. So then, so squeeze theorem, or sometime called the sandwich theorem, okay? Or you can say the sandwich sandwich theorem. So let me tell you. See, let me tell you the first the statement. So let fx, gx, and hx are three function. Okay, man?
Okay.
Yeah. Defined it near A. So A can be infinity and minus infinity. Okay. So let me include like this. So near A is in between minus infinity and infinity. It can be infinity. So I make a closed parenthesis here. Okay, man? And fx less equals to gx less equal to hx, and limit x tends to a fx equal to limit x tend to a hx. Okay, man? So the this function limit and this function limit are same. The f function and h function has same limit at the point A. Then limit x tend to a gx equal to, so let's say the common limit is L. So 1 second. So let me write here the common limit L. Then this limit also L. Okay. Okay, Mayan?
Okay.
Right. So we will develop this inequality first. We always calculate limit of the middle function. We take the help of two function, this and this. This you can call the helping function. Both this and this. This two call the helping function. That we calculate. And we evaluate the limit of the helping function, and we check both function has same limit. Then the middle function, that function will given in the question will have the same limit. Okay, man? Solution. I mean, example. Let's say example 1. So that limit extends to infinity, sine of sine cube x plus cos x divided by x square equals to 0. Okay, Mayan?
Okay.
Right. We see that. So this is our gx function here. We will find fx and hx. So the solution. Just carefully observe what we are doing here. See, we are interested limit extend to infinity. This means x taking very large amount of value. We are going, to infinity side. Here origin, we are tending to infinity this way, right? So let me develop here the inequality. See, the function we know sin x value is always in between -1 and 1, right, man?
Yeah.
So sin qx value will be what? The sin q, that value will be -1 whole q less equal to 1 whole q, right? So sin qx is between 1 and -1. Now, what about the cos? The is also -1 and 1. So if you add these two, so we get -1 less equal to sin qx plus cos x and less equal to 1 plus 1. Is it okay, Mayan? Mayan, clear? Hmm? Did you understand or not? Let me raise. Let me write it here. Sin qx is between -1 and 1. Also, -1 less equal to cosine x less equal to 1. Now add these two. Okay, Mayan? So we get -1 less equal to sin qx plus cosine x less equal to 1 plus 1. Mayan, is it okay? Hello?
Yeah.
Is this line okay, Mayan?
Yeah, this is fine.
Okay. So what should we get? We get here -2 less equal to, this is sin cube x plus cosine x less equal to 2, right? Okay. Focus on class actually. Because if you not focus here, then you not getting the point actually.
Yeah. No, this is fine.
All right. And whenever I will ask, is it okay or not, just response, okay?
Okay, sure.
Right. So it will be -2 divided by x square less equal to sin qx plus cosine x divided by x square less equal to 2 by x square. Is it okay, Mayan?
Yeah.
Fine. Now see, this function limit, if you calculate limit extend to infinity -2 by x square, this is 0, right?
Yep.
Yeah. Also limit extend to infinity 2 by x square, that's 0. So by squeeze theorem, so limit of our function sin qx plus cos x by x square 0. Fine, got it?
Yeah, it's fine.
Very good. This way you have to do this kind of question, actually using the sandwich theorem. So one more example, let me give you. Okay?
Okay.
Yeah. Example 2. Squeeze theorem is very powerful theorem. Hmm. So let me tell you here one example that we have Okay, so here example. So that limit extend to minus infinity 5x square minus sine of 3x divided by x square plus 10, this equals to 5. Okay, Mayan?
Okay, fine.
Right. So here the solution. We will use the squeeze theorem. So how we do? See, most of the time they will give you sine and cos like that, because those two functions always lie between minus and 1 and 1. So whenever you have sine cos function, you always start with the function is between minus 1 and 1, then rest part you do. Okay.
Okay, sure.
Yeah, so here sine 3x we have. So we know sine 3x is between minus 1 and 1. So both side multiple by minus 1. Then what you get? Minus of minus 1 get are equal to minus of sine 3x get are equal to minus 1. Is it okay, Mayan?
Yeah, that's fine.
We multiple by a negative number.
So you always choose the sine or cosine.
Yes, yes. Always in the expression they will give you this kind of thing.
And what happens if there's both sine and cosine in the numerator?
Yeah, if you have both sine and cosine, we did an example here. You can see, right? This is the example. We start sine minus 1 and 1, then this part we took, and cosine minus, we add, then we get this bound, right?
Yeah.
If you have both function and you have to apply minus 1 to 1 for both function.
Sure.
All right. So let me see. So now this is 1 get are equal to minus sine of 3x is equal to minus 1. So what should we get? We get minus 1 less equal to minus sine of 3x less equal to 1. Right? So now both side we are taking 5x square. So 5x square minus 1 less equal to 5x square minus sine of 3x less equal to 5x square plus 1. Is it okay, Mayan? Clear?
Yeah, it's fine.
Okay, both side we divided by x square plus 10. That is a positive quantity. So we can do it. So x square plus 10. So 5x square minus sine of 3x divided by x square plus 10 less equal to 5x square plus 10. So this is your fx. This is your, so this is fx. You can think this is gx, and this is you think hx. Not need to write fx, gx, hx. Just you evaluate the right hand side and left hand side limit. Okay, and check they are equal. Okay, man.
Okay, sure.
So calculate. Now limit extend to minus infinity. Why I took? Because in the question they asked minus infinity, right?
Yeah.
Okay, so this 5x square minus 1 divided by x square plus 10. This is what? This is limit extend to minus infinity. Both numerator and denominator we divided by x square. So then we get 5, 1 by x square. And then we get 1 plus 10 by x square. We know extend to minus infinity. 1 by x has limit 0. So we get 5 minus 0 divided by 1 plus 0. So we getting 5. Okay, Mayan?
Okay.
Right. So what about limit? If you calculate extend to minus infinity, this one 5x square plus 1 divided by x square plus 10. So this is limit extend to minus infinity. 5 plus 1 by x square divided by 1 plus 10 by x square. So 5 plus 0 by 1 plus 0. So getting 5. Okay.
Yeah, sure.
Right. By squeeze lemma. 1 second. So not lemma. You call it is theorem. We get limit extend to minus infinity the middle function. Done. Got it? Okay, Mayan.
Yeah.
Should I give one more example? Or you understood? I think one more example I have to give you. Okay.
Okay.
Let me tell you one. Yeah. Okay. So example 3. So that limit extend to infinity uh, uh, cos square 2x plus sin x divided by 3 minus 2x equals to 0. Okay.
Okay.
Right. Okay. So here the solution. We apply the sandwich. See, we have cosine and we have sine. We know cosine 2x is always between minus 1 and 1. Right, Mayan?
Yeah.
Okay. If you take square, then what happened? Square will be between 0 and 1. Is it okay, Mayan?
Yeah.
Very good.
If you take square, then yeah, 0 and 1. I
Yes.
don't get why -1 when
If
why
you
you
take
go to
cube,
0.
if you take cube, then it will be negative 1 to 1. If you take square, even power, then it will be 0 to 1. Okay.
Wait, so wait, can you say that again?
Yeah, I'm saying if something, let's say a is between minus 1 and 1, then a square always in between 0 and 1. But a cube if you take, then that is minus 1 and 1. Okay.
So cosine squared is always between 0
0
and
and 1.
1.
Yes, square never can be square cannot be 0, I mean negative, right?
Yeah.
It always start from 0 and up to 1. Got it?
Okay, and then cubed is -1 and 1.
Cube is negative 1. Yes.
Same with to the power 1.
Yes, same material. Yes, exactly. Now this is for the cosine square. That part we have estimate. Now what about sine? Sine we know what? Sine is between minus 1 and 1, right?
Mhm. Correct.
If you add, then what you get? 0 minus 1 less equal to cosine square 2x plus sin x less equal to 1 plus 1. Hmm. So minus 1 less equal to we getting cosine square 2x plus sin of x less equal to 2.
Why do you
Okay.
add 1 to why do you add 1 and 1?
Huh?
Want to be 1 minus 1?
Which one?
Oh, never mind, because you're adding sine, so it's
Yeah,
okay,
this
okay.
we add this side, this and this side with this and this here, this, right?
Yeah.
Yeah, so we divided by both side. See, Mayan, the same question. The same question, here see, you have 3 minus 2x. X tend to infinity. So x taking very large amount value, right? Right, Mayan?
Yeah.
So if x take very large amount value, then this is a negative quantity, right, man? This part?
Yeah.
Yes. Large than 3 minus 2x is negative. Do you agree?
Mm-hmm.
So you are dividing by a negative number. Then what happened, man? The inequality will change or not? Yes, right?
Mm-hmm.
So it will be changed. Did you understand logic?
Yeah.
Because since 3 minus 2x is negative for large n of x, large, okay?
Mm-hmm.
Yeah. So what we are getting? So let me write it here. We are getting 2 by 3 minus 2x is less equal to cosine square 2x plus sine x divided by 3 minus 2x less equal to minus 1 by 3 minus 2x. Okay.
Yeah.
So if you calculate limit, then what get? So we get limit extend to infinity this side 2 by 3 minus 2x, that you can think 2 by x 3 by x minus 2. So this is 0 by 0 minus 2. So 0, right? Okay, Maya.
Yeah.
Similarly, limit extend to infinity 2 by 1 minus 1 by. So minus 1 by 3 minus 2x, that also 0. So by squeeze theorem, limit extend to infinity. Got it? Maya,
Yeah, because you're on both sides. What happens if there's two different numbers on both sides?
no. Different number mean the if you get two different limit, right?
Yeah.
Then squeeze theory not work. In the squeeze theory, we assume that both right hand and left hand both has same limit. Then you can say the middle part has that limit. That limit you getting. Okay?
Okay, sure.
Yeah. Right. Okay, fine. I think it's enough for the squeeze theorem, right?
Yeah, that's fine.
All right. So now we can start next. The that epsilon delta definition for several variable, right?
Mm-hmm.
Two variables. Here it is. Epsilon delta definition for function of two variables. So here it is. Basically, let me tell you in general definition. But in exam, actually, you get always they will consider at point 0, 0. So limit xy tends to AB, fxy equals to L. Okay, man. If and
Okay.
only. Yes. If and only. For each epsilon greater than 0, here exists delta greater than 0, such that fxy minus L is absolute value less than epsilon if 0 less than x minus a square plus y minus b square root is less than delta. Okay, Mayan?
Yeah.
Right. So let me tell you an example. We will use some inequality here. So before do the example, so let me tell you some standard example. Here, let me write it here. The box. You always you can use. absolute value of x always less equal to square root of x square plus y square. Okay, Mayan?
Yeah.
Very useful inequality. We are going to use here this. Right. So example. So that limit xy tends to 0 0 x cube y divided by, you know, let me tell you here that um, x cube y. Oh, 1 second. X cube y. So let me give you easy example first. This divided by square root of x square plus y square equal to 0. Okay, Mayan?
Okay.
Oh. Solution. Let fxy equal to xy divided by square root of x square plus y square. Okay. Now,
Okay.
yeah. Now, yeah. Fxy similar as like in the single variable, we have to calculate this. Xy divided by x square plus y square minus 0 absolute value. So what it is? This is xy by square root of x square plus y square absolute value. So this is absolute value of x, absolute value of y divided by square root of x square plus y square. Okay, man?
Okay,
LCM.
fine.
Yeah, absolute value of x is yes, less equal to this. So put it here. And this also less equal to this. Put it there and leave as it is. So this cancel out with this. So what we are getting? We are getting square root of x square plus y square. So what should we get? We get fxy minus 0 absolute value is less equal to square root of x square plus y square. Right?
Yeah.
So, okay, mine is clear.
Yeah, it's fine.
So now you choose epsilon in the next page. So let me write it here. So we have fxy minus 0 absolute value is 1 second, is basically less equal to square root of x square plus y square. So for your convenience, you can write like this: fxy minus 0 absolute value is less equal to square root of x minus 0 whole square, y minus 0 whole square. Choose epsilon greater than 0. Now,
Mhm.
yeah, fxy minus 0 absolute value less than epsilon if square root of x minus 0 whole square plus y minus 0 whole square less than epsilon, right? Okay, mine.
Yeah.
Let delta equal to epsilon because it's work. So what we get? Fxy minus 0 absolute value less than epsilon if 0 less than square root of x minus 0 whole square, y minus 0 whole square less than delta. So done. Got it?
Yeah.
Okay. Let me give you one more example. Little bit different way, but easy. Example 2. So that limit xy tends to 0 0 x cube y divided by x square plus y to the power 4 equal to 0. Okay, Mayan?
Sure.
Yeah. What is the different here with the previous example? Previous example, in the denominator we had x square y plus y square. Look at the previous example. In the denominator we had x square plus y square, right, man? This.
Yeah.
But here we have where it is x square plus y to the power 4. That will little bit challenging to us. But we remove this difficulty by clever way. Okay.
Okay.
Yeah. Solution. So you write down fxy equal to what? X sqy divided by x square plus y to the power 4, right? Now estimate,
Mm.
yeah, fxy minus 0 absolute value. So what is this? X sqy by x square plus y to the power 4 minus 0 absolute value. So what is this? This is basically x sqy by x square plus y whole to the power for this absolute value. So x sqy absolute value, and the numerator is a positive quantity. We not need to take absolute value. Okay, Maya. Yeah.
Okay, sure.
Very good. Now what is this? So this is absolute value of x sq into absolute value of y divided by this is what? X square plus y to the power 4. Fine, Mayan, fine.
Yeah.
Okay. All right. Now see, you have this. Now Mayan, remove y to the power 4 term. Now see, we know x square. 1 second. All right. Okay. So x square, right? X square, man,
Yeah.
this one is, let me write, x square less equal to x square plus y to the power 4. Do you agree, Mayan, on it?
Yeah.
Because y to the power 4 is positive, right? That's why it is
Correct.
true. Yes. So now if you know just take the reciprocal, then what you get? 1 by x square is greater equal to 1 by x square plus y to the power 4. Agree, Mayan?
Yeah.
So this means, so the y to the power 4 term we remove somehow. This less equal to 1 by x square. Okay.
Okay, sure.
Right. So what we had? We had fxy minus 0 absolute value is what? X this into y divided by this is what? X square plus y to the power 4. So you can think this is x sq absolute value, y absolute value into 1 by x square plus y to the power 4. And we know this is less equal to what? 1 by x square. Right, man?
Mm-hmm.
So therefore total expression is less equal to this into 1 by x square. Man, agree?
Yeah.
And this is what? This is basically absolute value of x sq, absolute value of y. X square we can write absolute value of x square. Right, Maya?
Mm-hmm.
So what we are getting? We are getting x absolute value, y absolute value. Agree, Maya?
Yeah.
And this is we know less equal to square root of x square plus y square. And this is less equal to x square plus y square. Right?
Correct.
Very good. So let me put here in this place. So what we getting? This is equal to this less equal to this, and this simplify this less equal to this. So total expression fxy minus 0 absolute value is less equal to square root of x square plus y square whole square, right?
Mm-hmm.
So what should we get? We get fxy. So let me write it here. So fxy minus 0 absolute value is less equal to what? X square plus y square, right, Maya?
Yeah.
So let me write in the next page. So we have fxy minus 0 absolute value is less equal to x square plus y square. So this imply you can say fxy minus 0 absolute value is less equal to, let me put here square root x minus 0 whole square plus y minus 0 whole square root. So you have to take square here, right?
Yeah.
So let epsilon greater than 0. Now fxy minus 0. This less than epsilon if square root of x minus 0 whole square plus y minus 0 whole square, that whole square less than epsilon, right, man?
Mm-hmm.
So what we get? Fxy minus 0, this is less than epsilon if square root of x minus 0 whole square less than epsilon square root, right?
Yeah.
So let f delta equal to square root of epsilon. So what we get? Fxy minus if square root of x minus 0 whole square delta, where delta equal to square root of epsilon. Fine, man, clear?
Yeah, fine.
Yeah. This is a little bit tricky example because here what we had x square plus y to the power 4. So as usual we did it. So fxy minus 0, that this kind of thing. The only part, this is the problem, x square plus y to the power 4. That problem we solve by using this inequality, that x square we know less equal to x square plus y to the power 4, then this kind of thing, so this, and then this one, this, right? So 1 by x square plus y to the power less equal to 1 by x square, then we did this, right? This thing, and then this less equal to this expression. So here this is this kind of thing. All right.
Okay.
And finally we get this, that this mod absolute value less equal to this. Now this we can rewrite this way, x minus 0 whole square, that's square root a whole square. Now this less than epsilon, if this expression less than epsilon, so square you have take this side, square root you take. So this square root, so that is delta, right?
Yep.
Right. Okay. I think we finish it. So I will send you a new link where I will see. So I think you can solve the question where limit does not exist. You can select different path and you can do it, right, Maya?
Yeah, that's fine.
That's fine. Okay. I think we finish all the topics that you have in the quiz, right?
Yeah.
You will get two video in my YouTube link. I will send now. Okay.
Okay, sure.
Okay.
That'll
Bye.
be good.
Okay.
I'll
Thank you.
look at that then.
All right.
All right.
Thank you. Good luck.
Thank you for the
Bye.
class.